Today, we're going to be talking about systems development life cycles. It is going to be a long presentation, so just sit back and relax, and I'm sorry for the length of it. All methodologies revolve around 5 high-level activities: requirements, analysis, design, implementation, and test. So what do I mean by that? Well, the first thing is if you want to build a system, you need to figure out what the user wants. So we have to do requirements gathering. We interview the user. We ask them questions about the system. What is they're looking for? We try and analyze the requirements to make sure that we fully understand the problems and opportunities available. We design the most appropriate solution given the problem to solve. We implement it by building the software, and ultimately we test it as well. This methodology has been in use for many, many years now, and in the early days, we started with a methodology based upon these principles called waterfall. We're going to spend the next slide or two talking about waterfall methodology in particular. With waterfall method, what we wanted to do is take each of these steps in order, and we would actually complete each step before moving on to the next. So if we had a project that was going to last 2 years in length, we might spend the first 2 to 3 months gathering all the requirements for the system, interviewing users, asking them what they want, trying to understand the problem. Next, once we had all the requirements, then we'd move to analysis. So we'd try and figure out, do we have a good handle on the problem? Do we know what issues are there? The next step would be to design a solution based upon the requirements and needs of the user. Eventually, once we'd designed the entire system and all the software, we would then set about implementing it or building it, and that would take months. And then ultimately, once all the software for the entire system was built, we would test it and then roll it out to the users. So again, if the project was 2 years long, we'd spend several months in requirements, several months in analysis and design, probably a year building the system, and a couple months testing. And that did sound logical, but there's a lot of problems associated with this method. So I'm going to talk about it on the next slide. Unfortunately, when building systems using the waterfall method, there's a lot of problems associated with it. The first one is just long delivery timelines. If it takes 2 years to build the system, then you don't even start reaping any of the benefits until probably the year after that. The next thing is it was very difficult to adapt to any changing requirements. Because we spent so much time analyzing the system and then building the software, the business would change around it. And in fact, some of the requirements that were identified up front at a system, by the time a year or two passed, those requirements went away in entirety. So that was a real issue as well. You weren't able to validate the system quickly either, because it took 2 years before the user saw the system and before you rolled it out. Again, if they weren't part of the process, they didn't feel like they were part of the process, and a lot of times they just pushed back on the system because they didn't really understand it. And it was a huge change in many situations to try and implement at one time. And I think lastly is really transparency. The issues really revolve around the end users not being able to see what the IT people are doing when the system is being built. They're spending all this money for a system, and yet they're not seeing any activities for a year or two. And that's a huge problem. And we knew through a lot of failed projects that waterfall was not the best way to do this. So the solution was a thing called iterative methodologies. So iterative is just like waterfall. We still use requirements, analysis, design, implementation, and test. But the difference is that we try and break the system development effort into very small cycles or iterations. So what do I mean by that? In a typical system, you might have 100 different requirements that people want in the system. Using an iterative method, what we would do is we would organize those requirements from most to least valuable, and then we'd take it in bite-sized chunks. So we might take the first 10 requirements. We would then go and analyze it, design, build the software, test it, and actually roll that piece out to the end users. Then we would look at the next set of requirements, the next 10 on the list, and we would then adapt what we've already built to add this new functionality into the system. So basically, if you had 100 requirements and you tried to every 2 weeks deliver 10 requirements, then again, over a period of time, you'd be able to deliver the system and do it in a very methodical way. And by breaking this up into chunks, it allows users to be part of the process, to give you feedback early into the process. And if there are changes in requirements, you can easily make those changes. And that's what's important. So when we talk about these iterations, we still have to have a vision for the system. So at the beginning of a project, we will sit down with users and carve out what is the vision for the application. And in fact, we will document that in what's called a vision document. With the iterations themselves, we will then go ahead and take the requirements that were outlaid in the vision, break them into these iterations, and then we will go through the process one iteration at a time. And these iterations, or they're also referred to as time boxes, are usually in a length of about 2 to 4 weeks at a time. So that's kind of what we try and do, is we try and take this about 2 to 4 weeks, one step at a time. There are actually, when we talk about iterative methodologies, there are actually two basic types: predictive and adaptive. With predictive methodologies, they focus on still breaking it up into steps, but doing a lot more planning in terms of the process. So we might, even though we break it into small steps, we might create a comprehensive plan to basically cover off the entire project. Adaptive, which is the one that I'm most fond of, is one where we focus on the ability for the team to readily adapt to any changing requirements. There's much less focus on planning and much more emphasis on being able to understand the requirements and build them quickly into the solution. The adaptive methodology that I like to use is called Scrum, and that's what we're going to focus on for this presentation. Scrum, as I've mentioned, is an agile process, or an iterative process, that allows you to focus on delivering the highest business value in the shortest period of time. When I talk about the time frame, we're going to be using these iterations in terms of 2 to 4 weeks, and we actually call them sprints. So if you are using Scrum, you'll be very familiar with the term sprint. What's going to happen in this methodology is really teams will self-organize to determine the best way to deliver the highest value features. Traditionally, we would have had a project manager or some manager within the organization dictate which developer is going to work on whatever piece of the system. But usually in Scrum projects, the development team is allowed to select what they want to work on next. The nice thing is that every 2 weeks to 1 month, anyone that's interested in this project can actually see the project grow over time. You can deploy pieces of the project out early. Users can get value very quickly into the process. And that's why Scrum has become so important in delivering IT systems. So when we think of the characteristics that come along with Scrum, the first thing, and I've already mentioned it, is we have self-organizing teams of developers. The next thing is the iterations. We have a particular term, we call them sprints. The list of requirements in a Scrum project is actually referred to as the product backlog. So when you build requirements for a system, you're going to actually be creating a list called a product backlog. That product backlog is sorted from most valuable requirements to least valuable. So the requirements that are going to deliver the highest value in the end product will be towards the top of the list. There is no specific engineering practice prescribed when using Scrum. It's actually quite open and malleable, and it really can be used for any development method or for any development tool, and it can actually be used in a lot of different industries as well. So what is this methodology then? So to look at it at a very high level, it all starts with developing the product backlog. So the product backlog is simply a list of requirements for the entire system. When we want to start a sprint, we then have to take a subset of those requirements and add them into what's called the sprint backlog. So you might have 200 items in the product backlog. You're going to work on 10 items this week or during this sprint, and you'd actually create a sprint backlog of those 10 items. As mentioned before, you're going to spend about 2 to 4 weeks developing the system. And again, that's referred to as a sprint. Every day that you're working on a project, we usually have what's called a daily Scrum meeting. So it's just a real quick get together, 5 to 10 minutes, just to talk about the methodology, the progress of the project. And in fact, I've got some slides that cover it a little bit later. And then at the end of every sprint, so at the end of each 2 to 4 week period of time, you have what's known as a potentially shippable product. So you have to make sure that if a requirement is added to the sprint backlog, that the team will be able to develop all of the software within that sprint, test it out, and be prepared to ship it to the customer at the end of that sprint. So that's at a very high level what the process is about. So to recap, Scrum projects are done in a series of sprints. They're 2 to 4 weeks in length, but typically 2 weeks is kind of the standard in the industry. They are fixed. So if you start a project using Scrum and you're using 2-week sprints, you would usually use 2-week sprints for the entire project. You want to be able to maintain that constant duration. It makes it easier on everybody. And as mentioned, the product is really analyzed, designed, coded, and tested during the sprint. One of the things that we don't want to do is we don't want to make any changes during a sprint. So once you've planned out the sprint, you've committed to doing it, you leave it that way till the end of the sprint. And if you have to do any replanning, then that goes into the next sprint. But it's absolutely forbidden that you don't make any changes to what people are working on during that sprint. When we talk about Scrum, we have to look at it from really a framework perspective. There's very specific roles defined. There are very particular ceremonies involved, and there are specific documents or lists, and we call those artifacts. So I'm going to go through them in a little bit more detail. So what are the roles? Product owner, Scrum Master, and then the development team. So what's the product owner? Well, the product owner is really the subject matter expert. They're the end user. They're the person that decides and defines the features of the system. They decide what goes into a release and how best to package it up. They're responsible for trying to not only justify the dollars being spent on the project, but be able to justify whether it's worthwhile for the company to do it in the first place. The product owner is also going to prioritize the features, and again, based upon the value of the deliverable itself. The product owner is going to adjust the features and the priority for every iteration or for every sprint. So they'll be constantly adding new items to the requirements list, the product backlog. They'll be taking items off the product backlog. And so they're the ones that are kind of setting the tone for the project. And ultimately, they're the ones that will have to accept or reject any of the deliverables that the team produces. The Scrum Master is really somebody from the development team that represents the management of the project. They're really there to enact Scrum values and practices and remove any kind of impediments that might stand in the way of the team being successful. So they're really there to kind of shield the team from external influences and to really kind of make sure that the projects run smoothly. But many times the Scrum Master is not a project manager for the team per se. Sometimes they are, sometimes they're not. But they're really just there to make sure that the process is being followed and that the system development is moving forward in an expeditious manner. The team itself is usually 5 to 9 people in size. They're usually cross-functional in nature. They're usually UX people, developers, testers, whatever. They're usually full-time members of a team though. And maybe not in every situation. So you might, for example, need to have a DBA assigned to the team from time to time. They may be part-time, but most developers are expected to be on the project full-time. Teams are self-organizing. They typically don't have titles per se. They really have kind of roles. So you have one person that might be a UX person and may do testing. Another person might do developing and DBA responsibilities. But we really don't, we kind of dispense with job titles. That's really not important. We also, team members may be swapped in or swapped out between sprints. So you might start with 8 people on the first sprint. At the end of that sprint, they might move an additional person onto that team. And that's likely, but you don't make any changes during a sprint. So that's the team. The next is the framework for doing this. So let's talk about sprint planning first before we talk about review, retrospectives, and then the daily scrum. Sprint planning. What we try to do is we try and have the team take a look at the product backlog, and based upon their availability, so how much time they have available, they try and figure out how many requirements they can finish within a given sprint. So they sit, they analyze it, and eventually what they do is they take items out of the product backlog and move that into what's called the sprint backlog. So they actually identify requirements, and then they plan out the sprint fully. To plan out the sprint, first of all, you got to remember that whatever is put into the sprint plan, the team is committing to get that done by the end of the sprint. So what they'll do is they'll go ahead and in that plan, they'll identify a requirement. So here's one here. As a vacation planner, I want to see photos of the hotels. Okay, so that's fine. So that is a requirement. And then as part of sprint planning, what we'll do is we'll break it down into a number of subtasks. So we need to code the middle tier, code the user interface, write test fixtures, code up the application, and then do some performance testing on the code. So as part of sprint planning, for each requirement, we actually break it down into the individual tasks that developers must perform in order to fulfill the requirements that are in the plan. The daily scrum. As I mentioned before, it's just a meeting that happens every day, usually at the beginning of the day. They usually last 15 minutes or less. Usually people have to stand up in the room when they attend these meetings. I'm not kidding. It's because when people sit, they get too comfortable. So generally when we do the daily scrum, it's a stand-up meeting. And we're really not trying to solve the entire world's problems. All we're trying to do is really do a recap of where we are in the development and figure out, is there anything that's really inhibiting our process to move forward? Have we discovered any technical challenges? We had a challenge. How did we solve it yesterday? So it's really kind of just touching base every day just to see how everybody's doing and keep the ball moving forward. One way to organize the daily scrum is to actually go around the room and have each developer answer 3 simple questions. What did you do yesterday? What will you do today? And is there anything in your way? So again, that just helps extract from those people, are we moving forward and is there anything impeding the process? At the end of each sprint, we typically do 2 things, a sprint review and a sprint retrospective. The sprint review is just an opportunity for the users of the system to see what the development team's done in the last 2 weeks. So usually what we do is at the end of the sprint, we have a short demo. The whole team will participate. They'll show the user what they've done. They usually invite everybody that's interested in it and get feedback. So it's really an opportunity for users just to see every 2 weeks what's happened during that sprint. The next thing we do is really more of a team-focused activity, which is called a sprint retrospective. So at the end of the sprint, we typically take about 15 to 30 minutes and just the development team participates. And what we do is we just talk about the sprint. We identify, what we've accomplished, what kind of design hurdles we have. We talk and look at notable design pieces of the system. We've looked at how the system's evolved, and we really talk about going forward, how is this going to change what we do next. One of the things that a technique that a lot of teams use to try and drive that discussion as well is using a thing called a stop, start, continue exercise. And you wouldn't do this every sprint, but you might do this every month or two. You might get the whole team together and you might ask them, so what should we start doing that we haven't been doing? Should we be including the UX people more? Should we use an outside consulting firm to give us feedback? Should we involve more testing? So what should we start doing? The next thing is we ask everybody, what should we stop doing? So are there things that are really inhibiting our progress that we really need to stop? Should we stop talking to the government regulators because it's not impacting what we do anyways? And then continuing doing, which is the last one, is what have we done that's been helpful? What should we continue to do and to really help us get to the end goal quicker? As I've mentioned before, there are a number of artifacts, and I've alluded to them already. So the first artifact is the product backlog. It's really just a list of requirements. It's a list of the work that's desired. And it's always expressed as a value to the end user. And in fact, we use a very particular format for these requirements. And the format is as a role, I want to do something so that I derive some value. So as a guest, I want to cancel a reservation because I no longer need that hotel stay. That might be a good requirement. This is just a sample product backlog. Again, there's a lot of different formats, and you'll actually, the students in this course are actually given a particular format to use for the product backlog. Each sprint should actually have a goal associated with it as well. So again, you might, for a particular sprint, you might want to make the application run on SQL Server in addition to Oracle. So that might be a good goal. So it's usually good to have, to be able to describe to users and developers what is the goal of a particular sprint. In the sprint backlog, we, as mentioned, we usually like to have a list of subtasks. And what we usually do is we record our time against those subtasks. So if the subtask was to code a user interface, if I'm a developer, I'm actually going to record my time that I spent 8 hours on Monday, 4 hours Tuesday, and 8 hours on Wednesday actually coding the interface. And that on, these other activities, those were the actual times I spent on them. So that's all we're trying to do here is usually we have a list of very detailed tasks, and we usually try and record the amount of time spent against each one. For this actual slide, these times would be for an entire development team. In terms of the sprint backlog, any team member can add, delete, or change the sprint backlog. And again, we usually do that during the planning process. It is sometimes required as you start to develop something. You might have to add additional tasks because you might not have understood that that was required at the beginning. So you're free to go ahead and add tasks. I would ask you not to remove any tasks, though. I would just record no time against it. But again, you can, although we typically don't add new requirements to a sprint, we certainly can add tasks or subtasks to a requirement when we're actually building it in a sprint. What's nice to have too is we can actually take the information that we're collecting and actually do it in more of a graphical format. So in graphing the data, they use what's called a burn down chart or a burn up chart. Two different names, but same basic principle. And all you want to try and do is understand at the beginning of a period of time, usually, for example, at the beginning of a sprint, how many hours that you've got available to work on. And as you deliver parts of the system and you keep readjusting your timelines, again, you should see the amount of time left to develop the system fall over time. So the chart in front of you just shows that we've got 800 hours to work on a system. And then as we work through the system and as we start to realize how good our estimates are, we can then refine our estimates and eventually, hopefully, get to a point where there's nothing left to be done. One of the questions that's important to ask about Scrum is what happens in terms of scalability? Well, each team is usually comprised of about 7 to 9 people. If you get beyond 7 to 9, it really makes it difficult to handle team sizes larger than that. But you can use Scrum on very large projects. There have been Scrum projects that have had more than 500 people working on it at one time. So when we want to scale a project, if we want Scrum, if we want to speed up the development effort, and we want to have a lot of people involved, then we use a methodology called Scrum of Scrums. So with a Scrum of Scrums, what we typically would do is we would have different Scrum teams. So we'd have maybe in this case 3 teams of people. So there'd be a group of 9, a group of 7, and a group of 9. And then each one of those would have their own sprint backlog. And then typically you'd have a small group of individuals that are there to kind of act as like a traffic cop and shuttle information between these teams. But you can have very large projects and project teams. And the way we do that is by using this kind of scaling approach by having parallel Scrum backlogs and parallel Scrum teams working on it. And again, we can have even larger groups of scaling where you can have not one group of overseers, but you can actually have several groups of overseers that then oversee, small groups of Scrum teams. So you can get very, very large projects going. So there's a lot to learn about Scrum and about Agile methodologies. And I've provided a couple of sources here. So I'd suggest you go there. There's some documents that you can read as well by Craig Larman and Mike Kahn. So again, they're readily available, and I would encourage you to take a look at some of this information. And that's it, folks. So if you have any questions, please don't hesitate to ask me. I'm always happy to answer. Anyways, I hope you enjoy using Scrum in this semester and at the job site as well. Thanks.